Hey folks, welcome back to our rundown of Nielsen's 10 heuristics. As you'll recall in the last video, we went through our first four. In this video, we're going to do numbers 5, 6, and 7. So let's go ahead and jump right in with number 5 here, which is we want to match between our system and the real world. So as you'll recall, each of these heuristics has a definition that captures most of the meaning of the heuristic, and all of these definitions come from Nielsen himself. And so Nielsen describes this heuristic as the system should speak the user's language with words, phrases, and concepts familiar to the user, rather than using system-oriented terms. Follow real-world conventions, making information appear in a natural and logical order. So I like to think of this heuristic as having two parts. In the first part, we're thinking about speaking the user's language, and in the second part, we're thinking about a more general version of the same idea, which is making sure that information appears in a natural and logical order. So let's go through this part 1 and then part 2. Speaking the user's language. This is a great example of a success in terms of speaking the user's language. Those of you who are computer scientists know that we refer to matrices usually in a zero-indexed fashion. So the first cell here, the one that's highlighted, would be 0, 0. This is from Excel, and Excel has learned to speak the user's language. It doesn't call this 0, 0, it calls it A1. The 1 is because most human beings, other than computer scientists, count starting from 1 rather than 0, again, speaking the user's language rather than the system's language. And the A is because people have a hard time remembering what a row is, what a column is, X, Y, et cetera, et cetera. Quite frankly, I think sometimes computer scientists do themselves. Does that 0 refer to the row or the column or so on and so forth? So Excel has done a really good job here and has indexed all of its cells in Excel by A1, B1, C1, C2, et cetera, rather than using system terms as it's probably implemented, which starts from 0, 0. Another good example of speaking the user's language comes from airplane mode on most smartphone operating systems. What airplane mode does is it turns off radios. But if you had a radio icon there and the text associated with it was turn off radios, the vast majority of users would say, well, wait a second. I don't have a radio on this phone. Do I have a radio? Can I tune into FM and AM stations and so on and so forth? Instead, they're speaking the user's language. They're saying the only time you'd really want to do this is on an airplane, so we're going to call this airplane mode. We're not going to use the term radio at all. That stays within the system development team. Okay? When you're trying to speak the user's language, metaphors can be helpful, but they also can be misleading. A great example comes from emptying the trash or emptying the recycling bin on Windows. This is from Mac OS. When you empty the trash or empty the recycling bin, using that metaphor, it tells the user, hey, the things that are in the trash, in the recycling bin, those things are gone forever. The garbage folks have come and picked up the garbage, never going to see this again. In most cases, that's true, and it really has communicated a pretty complicated idea, the deletion of a file on a disk, to a user in a way that's understandable, but it does have some risks too. Those risks are associated with the fact that, in fact, in most cases, the file doesn't actually go away, especially when we're talking about older file systems and older disks, right? It just what happens is the operating system says, hey, I can write over this spot the next time I need some space. And this, in the vast majority of cases, is not a problem. But if I were to take a computer that had a whole bunch of files that were important, say financial documents, personal documents, that were in the trash, and the trash was deleted, and a user took that computer and gave it to their cousin or sold it on eBay, that's a concern because the files actually can be recovered pretty easily, even though the user thought that by emptying the trash, those files are gone forever. So metaphors can be helpful, but they also can be risky. Think carefully when you use metaphors. Okay, let's go on to the second part of this heuristic, which is making sure that information appears in a natural and logical order. And this is a great counterexample. Don't do this. This is a website from National Public Radio, which is our version in the United States of the BBC or the CBC. This is a map that shows the bikeability of each state in the United States. And it does not show information in a natural or logical order. A natural or logical order of this information would show more bikeable states as darker red or darker green or something, and less bikeable states as lighter red or light green. Instead, they've decided to vary the color or the hue, and you can pretty easily see the problems with this. Minnesota here Can you a priori tell whether it's very bikeable or not very bikeable? No, you have to go to the key and really study it. And you have to go to the key for every single color, which wouldn't be the case if they had varied the brightness rather than the hue or the color in this map. This is kind of a classic fail along the lines of making sure that information appears in a natural and logical order. Another, perhaps even more classic fail comes from light switches. Whenever you have a large group of lights, very famously or very traditionally in terms of how this material is taught in a classroom, right? Very often a classroom has, 8 different lights, and they often appear in horizontal order, but the lights themselves are spread out all over the room, right? So in this case, we have 2 in the front and 2 in the back, but the user is supposed to know that, okay, these 2, this one goes here, this one goes here. This is not a natural and logical order. A natural and logical order would have 2 buttons here, right, and 2 buttons here. 2 switches here, 2 switches here, right? This is a classic issue with light switches that hopefully in the future we'll be able to fix. Now that we're entering the world of the smart home, I thought this might be fun and show you that this problem has replicated even to this new smart home world. This is the app for the Lifx system. My wife and I invested in 4 smart lights to see what's going on with this whole smart home thing. And we, in general, love these lights. They're very bright, they're very fun, but they have the same problem as classic light switches in their mobile interface. We have lights that are labeled, but it doesn't say where they are in the house, right? I wouldn't say this is as serious of a problem as, for instance, the light panels in classrooms, because light panels in classrooms are used by all sorts of people. You don't do them very often, so it's hard to learn, and they don't typically have text associated with them like the Lifx app does. But to me, this is still a pretty serious violation of the natural and logical order component of this heuristic. So I'd give it a 2 rather than a 3, but that could be a judgment call. I did notice when I was putting together these slides that people are thinking about fixes for this issue in the future. This is a fun light switch concept by 2 folks who have essentially set up an idea where the lights themselves are represented in the light switches exactly where they are in the room, which would be a perfect light switch setup according to this heuristic. Okay, that's it for match between system and the real world. Let's move on to error prevention. This is a big one. This is an important one. We've seen it a couple times through examples, but now we'll go through it in more detail. All right, let's do Nielsen's definition of error prevention, our 6th heuristic. Even better than good error messages is a careful design which prevents a problem from occurring in the first place. Either eliminate error-prone conditions or check for them and present users with a confirmation option before they can commit to the action. So as I said before, we've seen a lot of examples of failures along the lines of this heuristic. So we saw that Google Maps allows people to route themselves through war-torn areas. Way back in course 1, we saw an example of a system that allowed users to, chemotherapy system that allowed users to give patients more radiation than any human could possibly need as part of their chemotherapy treatment, which is a clear and very serious violation of this particular heuristic. Another very important one, although on the financial side versus ultimately the most important on the human life side, is this example. I don't know if you folks have noticed, but very often airlines, once or twice a year, airlines will have a situation where they accidentally issue a fare that is ridiculously low. So in this case, Delta accidentally issued a fare from Boston to Honolulu for $64, right? And then there's a news story about will they honor the fare, won't they honor the fare, and so on and so forth. This is the type of thing that in the pricing system should be considered a failure of this heuristic, and I'd say 4 because it's millions and millions of dollars. The impact is quite large. Okay, so when you're thinking about this heuristic, I like to think of this quote from Laupheimer, who works with Nielsen. I'll show you a reference to Laupheimer's articles in a second. Laupheimer writes that the designer is at fault for making it too easy for the user to commit the error, or in other words, when you're thinking about this heuristic, your philosophy should be there is no such thing as user error. When an employee of Delta entered that $64 fare, that is the designer of the pricing system's fault, right? We have to resist saying that users are stupid or did stupid things. We have to treat all user actions as potentially our fault. Same deal with Syria, the Syria routing example, and so on and so forth. Just as a quick refresher here, when we're talking about errors, we're talking about two types of errors in particular, right? These are the two types of errors users typically make in a system. The first is a slip. So a user intends to perform one action, but ends up doing something else. One version of this that's quite common is the autopilot error. So when you're doing something and there's a slight variation from what you usually do, you do what you usually do and a slip happens. The second type of error is a mistake. This is when your goals are inappropriate. So when the user wants to do something that really they shouldn't do. Now, regardless of whether you're dealing with slips or mistakes, there are a couple solutions you can offer, along with marking that each heuristic, or along with marking that there's an issue with this particular heuristic in a system. I also like highlighting these solutions because I think it helps us understand the meaning of the heuristic a little better as well. Okay, so when you notice an error-prone situation, when you see a violation of this heuristic, one potential solution is to double-check with users, right? So when the Delta Airlines employee is typing in a $64 fare, your system might have some code in it that would pop up a message that says, you know what, your fare is greater than 2 standard deviations below your competitors right now. Are you really sure you want to do that? And in some cases, they might say yes if there's a sale, right? But in most cases, they'll say, oh no, that was a slip. I didn't mean to do that, right? So double checking with the users is a great way to solve problems associated with this particular heuristic. Another is providing helpful constraints. This is particularly good for slips. So for instance, on Google Flights, if you try to route yourself from Chicago to Chicago, for instance, you mix up the two boxes, or you're watching TV or something along these lines, Google will say, no, you can't do that, rather than showing you that there are no flights from Chicago to Chicago, right? It says, this is a constraint, we won't allow this, and then the user will realize, oh, I didn't mean to do that, Chicago to Minneapolis is what I actually meant. Another version of this constraint might be, right, to say, hey, user, we don't think we can route you to Jordan right now because you have to go through Syria, or we can't give you the fastest route. Okay, so the final solution to problems associated with this heuristic that we'll talk about is using previews. This is particularly important when a user is about to engage in a costly operation. It's particularly discussed when the cost is associated with time. So for instance, it requires a reset, or the computer has to process for 30 minutes, something along these lines. This is a great example here. In iOS, you can choose 2 different sizes for your icons. The standard size and a larger size, but it requires a restart, right? So what Apple has done smartly here is it allows you to preview the size of the icons before you restart, so you don't have to go through a 2-minute long operation just to see effectively what your options are. So this is a great example of a solution to a potential error prevention violation, right? So if you're interested in learning more about preventing user errors, I really like these 2 articles from the Nielsen Norman Group. You can see the URLs here. Take a look at them if you're interested. Okay, so let's go and move on to our third and final heuristic of the video. This is visibility of system status. So Nielsen defines this heuristic as follows. The system should always keep users informed about what is going on through appropriate feedback within reasonable time. So just from experience, I've found that this heuristic breaks down into 2 corollaries. The first is that for all operations greater than a few seconds, feedback about the progress of that operation is absolutely essential. And the second is that modes are dangerous, they should be used minimally, and when they are used, they have to be very, very visible. So let's go through this one by one, starting with feedback about operations greater than a few seconds. This one's really pretty simple, and I made a little diagram to help us understand. So when we're making things, when things are very invisible, so this would be a serious violation of this heuristic here. This is the situation that we've all found ourselves in at times when we're trying to click, right? The computer's doing something, we're trying to click, but nothing's happening. We don't know exactly what the computer's doing. We don't know how far along it is in doing what it's doing. This is very not visible according to the visibility of system status heuristic, right? And it can be a problem ranging from 1, 2, 3, or 4 on the heuristic evaluation scale. One way to a quick and dirty way to fix this is to use the beach ball or the Windows progress cursor, right? If you're developing an application for Mac OS or Windows, this happens actually automatically sometimes when the computer is doing something. So Apple and Microsoft have helped you make your user interface accord to this particular heuristic. But the best thing to do is to do a progress bar, right? This makes the system status very visible. It shows you what is happening. In this case, there's a copy. It tells you, what's going on, and in general, it'll tell you how far along it is, right? So it'll say 62%, 73%, and so on and so forth. So this is the ideal case according to this heuristic, and this is a violation of this heuristic down here, right? The system status is completely invisible. System status is very visible. Okay, the second corollary of this particular heuristic is that modes are dangerous. They should be used minimally, and when they are used, they should be very, very visible. So just to make sure that we're all on the same page, a mode is a setting in a user interface such that the same input will result in 2 or more different effects. Classic example of a mode is the caps lock key. Hit the caps lock key, I type in A, I get an uppercase A. Hit it again, I type in A, I get a lowercase a. Classic mode, right? On, uppercase, same input, off, lowercase, right? So same input results in different things depending on whether the mode switch is on or off. Another good example is the bold button or the italics button or the underline button that occurs in many different text editing applications, including PowerPoint here. A fun example is the keyboard layout mode that is in most operating systems, right? So I can switch my keyboard to Spanish where the same input will result in different output than if my keyboard layout is in the US keyboard layout. So in your interfaces, there are going to be times where you're going to think, oh, you know what, I'll just implement a mode. If you can avoid it, you should. There are a number of ways to avoid it. We're not going to cover that in this course, but oftentimes common sense will do the job. Find a way to avoid the mode. Unfortunately, it's not always possible to avoid modes. For instance, consistency in standards, right, our fourth heuristic, that requires us to have a caps lock key. That more or less requires us to implement bold text in the same way, and I'd say the same thing is true also of keyboard layouts. So we're kind of in a box. We want to make sure our user interfaces are consistent and standard with norms, right? But at the same time, we want to avoid modes. In these cases, you go with the mode, but you make sure they're really, really visible. And in all 3 examples here, we see that this is very much true. The designers have done a great job making sure that the status of the mode is very visible. So for instance, the caps lock key. I'm sure it wasn't easy for Apple to implement a small little light on the caps lock key, but that tells us what's going on with the system. This tells me that the caps lock mode is on. I, as the user, can see that. It's visible. When I type A, I know that I'm going to get a capital A. Same deal here with the keyboard layouts, right? This little flag tells me I'm in the US keyboard layout mode. If I switch to Spanish, it's going to switch to a Spanish flag. I can see the system status is visible. The mode status is visible, right? Same deal here with the bold button. I can see that it's depressed. I know what type of text is going to be entered when I start typing, right? I know the status of the mode. It's pretty rare to find these days in commonly used applications violations of this part of the heuristic, right? Situations where there are modes, but the mode status is not visible. I did, however, find one good example from Google Maps. Here you can see I've routed myself from the University of Minnesota to Northwestern University, and it's saying that it's going to take me 9 hours. And having done this trip a couple of times, I know the actual amount of time is roughly 6 hours. And actually what's going on behind the scenes is that I have set some modes. I've told the Google algorithm to avoid tolls and avoid highways, right? But when I close this little panel here, that's no longer visible, right? And in the iOS version of actually Google Maps, these settings would persist. So you would be routing yourself, maybe once you decided you wanted to avoid highways, but you'd be routing yourself later and it's like, what is going on? Why is it giving me these weird routes that take a lot longer? That's because the mode wasn't visible, right? So I would actually say, this is the actual route you can see here with the correct versions of the mode for the user intent on. I would actually say that this is a pretty serious violation of the visibility of system status heuristic, a 2 or a 3. Right? It's going to result in a situation actually where users might look at that 9-hour route and say, you know what, I know this only takes 6 hours. I'm going to switch over to Apple Maps. I'm going to switch over to Big Maps because I know that system will give me the correct route. So this is a pretty serious heuristic evaluation issue. Okay, So that is it for visibility of system status. We'll continue in the next video with the final 3 heuristics.